In this video, we are going to talk about increasing and decreasing functions, the maximum and minimum value of functions, and then finally we will talk about concavity of functions. So now let's assume that we have a graph of x in the xy plane, and let's assume this is the x-axis and then the y-axis, and then this graph looks like this. Now you will see that at these sections of the graph, if we draw any tangent at this portion of the graph, that tangent will be greater than 0. So let's assume we trace this point down, and then we trace this one to down here, and then we trace this one up here, and then this one up here. So let's assume this is f of b, and then this is f of a, and then this is a and b. So to find the tangent, f prime of x is equal to f of b minus f of a divided by b minus a. So now, because b is greater than a, the numerator is going to be a positive value, and because f of b is also greater than f of a, sorry, here is a denominator, the denominator is greater than 0, and then this side too is greater than 0. So at the end of the day, we are going to get the tangent greater than 0. So the function is increasing at that point. But if we draw a tangent at this point, let's assume we draw a tangent here. Now if we trace this point to the y-axis, and we trace this one to the y-axis, and then we trace this point down here, and then we trace this one down here, and let's assume that here is D and here is C. You see that if we find the tangent f prime of x, is going to be f of f of a minus f of b divided by d minus c. Now you see that d is greater than c, so the numerator is a positive value, and then if we come, the denominator is a positive value, and if we come to the numerator, f of a is less than f of b, and therefore this is going to be a negative value. So at the end of the day, we will get the tangent less than 0. So at this point of the function, it is decreasing. So now anytime you want to find the range of values for which a function is increasing, you just have to find the tangent of that function on that interval, and if it is greater than 0, then the function is increasing at that point. But if the tangent is less than 0, then the function is decreasing at that point. So now let's consider another graph. Let's assume we have this graph. So x is here, and then here's y, and then we have a graph like this. You see that at this point of the graph, if we find the tangent here, it is going to be less than 0. F prime of x is going to be less than 0 here. But if we find the tangent here, f prime of x is going to be greater than 0. So the function is decreasing in this interval, but it is increasing in that interval. So this is the whole idea behind increasing and then decreasing functions. Now anytime you see that here it is increasing, so the tangent is positive, and here it is decreasing, the tangent is negative. But here it is decreasing, the tangent is negative, and here it is increasing, the tangent is positive. So anytime the tangent changes from positive to negative, you have a local maximum. And anytime the tangent changes from negative to positive, then you have a local minimum. Now, to determine the concavity of the function, all we need to do is to find the second derivative of the function. If we find the second derivative and it is greater than 0, then we are talking about a concave up situation. So this is concave up. And then if we find the second derivative and then it is less than 0, then we are talking about a concave down situation. So now let's define critical values. What are critical values? Critical values are the values for which the derivative of a function f of x is equal to 0, or the derivative of a function does not exist. This is the checklist for critical values, and this is going to become important as we continue in this video. Now let's consider these two functions, but first let's consider this one. This is a graph of f of x. So you see that at this side of the function is increasing, because if we find the tangent at this side, it's going to be greater than 0. But at this side of the function, it is decreasing. It is decreasing in this interval, and then it is increasing in this interval. And then at this side of the function, it is barely increasing nor decreasing. So this is what is known as the point of inflection. Now let's graph f prime of x from this function. So at where the function is increasing, we know that f prime of x is greater than 0 at that point. So in this region, we are going to be in this part, that is f of x greater than 0. Then at where the function is decreasing, f prime of x is less than 0. So in this region, we are going to be around this region of the graph, and this is increasing, so we are going to be on the top part. Now, but having said this, there's something I have ignored. At the local minimum and then at the local maximum, you see that the function approaches a constant. So the function is not changing here, and then it's not also changing here. So at this point, it's neither increasing or decreasing, and it's the same here. Now remember that if you find the derivative of a constant, you are going to get 0. So at this point, the function is 0 at this point, and then also at this point, the derivative is also 0. So now let's graph f prime of x from this situation. So now, but there is something I ignored. At the point of inflection, the function is neither increasing nor decreasing. But outside of that region or the point of inflection, you see that this function is decreasing. So we will have a concave up situation here in this case. But remember that we've already said at this point it is increasing. So this point is greater than 0. And then it begins to decrease in this region. So that is this region. And then it begins to increase again in this region. So this is how the graph of f prime of x is going to look like. And this is the point of inflection. At this point, the function is neither increasing nor decreasing. Now let's use that same understanding to sketch f prime of x from this graph. Now you see that in this region, the function is decreasing, and then it is increasing here, decreasing here, and then increasing here. But here, the function is neither increasing nor decreasing, so it is constant function here, and therefore the derivative here is 0. At this point the derivative is 0, and then at this point the derivative is 0. Now since this is decreasing, then we know that we are going to be in this region at that point. So this is how it's going to look like. But now there is a point of inflection here, but we know that the function is increasing to decrease. So that means that we are moving from a positive to a negative. If we are moving from a positive to a negative, then the point of inflection is a local maximum, and therefore this point of inflection at the f prime of x is going to be a local maximum. So let's join the points together. And then at this point, see that the function is decreasing. So the point of inflection here is going to be a local minimum. And therefore, here too it is increasing. So you see, this is f prime of x from that graph. So let's consider this function. Now, in what region is this function increasing? You see that in this region, the function is increasing, and it is also increasing in this region. And then in this interval, the function is decreasing in this interval, and it is also decreasing in this interval. So therefore, the interval for increasing is from b to d, and also from f to infinity. So therefore, the function is increasing from b to d. Now, we are using this bracket because the points b and d are not inclusive. Union, then it is also increasing from f and then infinity. Now, in what region is the function decreasing? The function is decreasing in this region. So from infinity to b, the function is decreasing all the way from infinity to b. So it is minus infinity and this positive infinity. Let me add it. So from minus infinity to b, and it is also decreasing in the region d and f. So union d and then f. Now, concave up. So you see that this is concave up. So from this interval all the way to this interval, the function is concave up here, and then it is also concave up from this interval to this interval. So we are talking about minus infinity and then c union this interval, which is e, and then infinity. So that's the region for concave up. Now let's talk about the concave down. Concave down, it looks like this. So you can see that this is the region in which the function is concave down. So we are talking about c and e. Now let's also talk about the local minimum. So which one, in what value will give us the local minimum? So you see that x equals f is a local minimum, and x equals b is also a local minimum. So we had x equals f and x equals b is a local minimum, and then the local maximum is at this point d. So for the maximum, local maximum, we are talking about x equals d. So using that same understanding, this is f prime of x. Let's find the region in which the function is increasing. So increasing. Now remember that we said for the region in which f of x is increasing, f prime of x should be greater than 0. So we are talking about this region. You see that this interval is greater than 0, and this one too is also greater than 0 from this up. So this is from minus infinity to a, and also from g to infinity. This is the interval in which the function is increasing. So we are talking about minus infinity to a union g to infinity. Now let's talk about the region in which it is decreasing. So everything below the graph is the region in which the function is decreasing. So for the decreasing, we are talking about a to d and then d to g. So that is a to d in union with D to G. Now, so let's come to the situation of concave up. So now, get the difference. If this was the graph of f of x, then all of this region will be concave up, and then all of this region will also be concave up. But this is the graph of f prime of x. So the only region that is concave up is this region from B and D. This is the region that is in areas where the derivative is increasing. Remember that we say f prime prime of x greater than 0 is concave up. So, and then also in this region. So for the concave up, we are talking about B and then D union F and then infinity. Then concave down. The concave down situation is this region, this interval. It is concave down here, it is also concave down here. So we are talking about minus infinity and then B union D and F. So let's consider the function f of x equals x squared plus 4x minus 21. In what interval is this function increasing and also decreasing? And what are the critical points? So to find the intervals for which it is increasing or decreasing, we need to find the derivative. So f prime of x is equal to, this is 2x plus 4. So now, let's find the critical point. The critical points are the point for which f prime of x is equal to 0 or f prime of x does not exist. So let's equate 2x plus 4 equals 0. In this case, we find out that x is equal to minus 2. So minus 2 is a critical value. Now let's sketch it on a number line. So let's assume this is minus 2. So now let's take values that are less than minus 2. For example, minus 3. If we put minus 3 in this equation, it becomes 2 times minus 3 plus 4. Now 2 times minus 3 is minus 6 plus 4. It is less than 0 because that is a negative number. So this is a negative value. And then now let's take values greater than minus 2. Example 0. If you put 0 in this function, 2 times 0 is 0 plus 4 is 4. That is a positive value. So now if f prime, so for here f prime of x is less than 0, that means it is increasing in this interval. And here, sorry, it is decreasing in this interval. And here f prime of x is greater than 0. So that means it is increasing in this interval. So in what interval is this function increasing? It is increasing in the interval that is minus 2 and infinity. So now let me add minus infinity and positive infinity to this side. So this is the interval for increasing. Now let's talk about the interval for the decreasing. So decreasing. You see that this is the interval for which is decreasing. In this interval, f prime of x is less than 0. So that is minus infinity and then 2. So that now let's consider the function f of x equals 2x cubed minus 3x squared minus 36x. At what point is it increasing? In what interval is this function increasing? And in what interval is it decreasing? What is the local minimum and maximum values? And then, is it concave up or concave down? So now, let's find f prime of x. That is equal to 6x squared minus 6x minus 36. So let's factorize 6 out. We are left with x squared minus x minus 6. So we need to look for two values that when you multiply, you get minus 6. But when you add, you get minus 1. So minus 3 times 2 is minus 6. But minus 3 plus 2 is minus 1. And therefore, this becomes 6 into bracket x minus 3. And then times x plus 2. So the critical values are at x equals 3. And then x equals minus 2. So now let's sketch this on a number line. So this is minus 2 and then this is 3. Now let's take values that are less than minus 2. Let's assume like minus 3. If you put minus 3 in this equation, minus 3 minus 3 is minus 6. And then minus 3 minus 2, plus 2 is minus 1. So minus times minus is going to give positive. So this region is positive. And then now let's come here. Let's take a value between minus 2 and 3. Example 0. If you put 0 in this function, now 0 minus 3 is minus 3. Then 0 plus 2 is 2. Minus 3 times 2 is minus 6. So this region is less than 0. Now let's take values greater than 3, assuming 4. 4 minus 3 is a positive value. And then 4 plus 2 is also a positive value. So this region is a positive value. So now let's write the interval for which this function is increasing. Now you can see that this function is increasing in this interval and also in this interval. So now let me put minus infinity and plus infinity here. So the interval is minus infinity and then minus 2 union 3 and then infinity. This is the interval for which this function is increasing. Let's talk about decreasing. This function is decreasing in this interval, which is minus 2 and then 3. Having found this, now you see that at minus 2, we are moving from positive to negative. So we are talking about a local maximum. So this is a local maximum point. And then from at x equals 3, we are moving from negative to positive. So we are talking about a local minimum point. So this is a minimum and then this is a maximum. Now let's find the concavity. So to find the concavity, we need to find the second derivative. And second derivative of x, we need to differentiate this. If you differentiate this, 6. If you differentiate x squared, you get 2x. If you differentiate minus x, you get minus 1. And if you differentiate 6, you get 0. So f prime prime of x is 6 times into bracket 2x minus 1. Now, let's find f prime prime of x equals 0. So 2x minus 1 is equal to 0. So x is equal to 1 over 2. So this means that the point of inflection is 1 over 2. At 1 over 2, the function is neither increasing nor decreasing. So let's sketch this on a number line. So this is 1 over 2. This is minus infinity and this is infinity. So let's take values less than 1 over 2. For example, 0. 0 is less than 1 over 2. If you put this 0 into this function, 2 times 0 is 0. 0 minus 1 is minus 1. Minus 1 times 6 is minus 6. So in this region, it is negative. And let's take values greater than 1 over 2. For example, 1. Now, if you put 1 here, 2 times 1 is 2. 2 minus 1 is 2. 2 minus 1 is 1. 1 times 6 is 6, which is a positive value. Now, remember we said if f prime prime of x is less than 0, then we are talking about a concave concave down situation. And if f prime prime of x is greater than 0, then we are talking about a concave up. So now, in what interval is this function concave down? We are talking about minus infinity and then 1/2. So this is concave down. Then concave up. It is concave up in the interval 1/2 and then infinity. Now let's consider this function g of x equals x exponent 4 minus 8x squared plus 1. In what interval is this function decreasing? And also in what interval is it increasing? So now g prime of x is equal to, if you differentiate x exponent 4, you get 4x cubed. And if you differentiate 8x exponent 2, you get 16x. If you differentiate 1, is 0. Now, let's factorize 4x out. We are going to get x squared minus 4. So this is difference of 2 squares. So this can be written as 4x times x minus 2, then x plus 2. So you see that the critical points are x equals 0, x equals minus 2, and then x equals 2. These are the critical values. So let's represent this on a number line. So we have minus 2, 0, and then 2. Then here's minus infinity. And then this part, this is not part. So in this part is minus infinity. So now let's take values less than 2. For example, minus 3. If we put minus 3 here, to be minus 3, then now minus 3 minus 2 is also minus 5. Then minus 3 plus 2 is minus 1. So you can see that minus times minus is positive. Positive times negative is a negative value. Now let's take a value between minus 2 and 0. For example, minus 1. Now here is minus 1. Then minus 1 minus 2 is minus 3. Then minus 1 plus 2 is positive 1. So minus 1 times minus 3 is plus 3. 3 times 1 is 3. So we have, it's positive in this region. Now let's take a value between 0 and 2. For example, 1. If we put 1 in this function, 4 times, so we are going to get 1. 1 minus 2 is minus 1. Then 1 plus 2 is 3. So 1 times minus 1 is minus 1. Minus 1 times 3 is minus 3. So this region is negative. Then let's choose a value between 2 and infinity. For example, 3. We have 3. Then 3 minus 2 is 1. Then 3 plus 2 is 5. So at the end of the day, 3 times 1 is 3 times 5 is 15. So this region is positive. So now, in what interval is this function increasing? So you see that it is increasing in all the intervals where f prime of x is greater than 0. So you see that it's in this interval. It's increasing in this interval. It's also increasing in this interval. So the interval for increase is minus 2 and 0, union 2 and then infinity. Then decreasing. Now, all the intervals for which the function f prime of x is less than 0, it is decreasing in that interval. So we are having, in this case, minus infinity and minus 2, union 0 and then 2. So the function is decreasing in this interval. Now, you see that at this critical point, we are moving from negative to positive. So we are talking about a local minimum. And at this critical value, we are moving from positive to negative. So we are talking about a local maximum. And then we are moving from negative to positive. So we are talking about a local minimum at that critical point. Now let's consider h of x equals 1 divided by into bracket x plus 3 times into bracket x minus 1 squared. Let's find the interval in which this function is increasing and also the interval in which it is decreasing. So we need to first find h prime of x. Now we need to use quotient rule in this case. So we maintain the denominator and differentiate the numerator. If we do that, we will get 0, because if you differentiate 1 is 0. Then minus, you keep the numerator, then you differentiate the denominator. But this is product of two functions, so you keep x minus 1 exponent 2 constant. Then you differentiate x plus 3. If you do that, you get 1. Then you add it to keep x plus 3 constant. Then you differentiate x minus 1 exponent 2. If you differentiate what is inside the bracket, x minus 1 is 1. Then times, if you differentiate x minus 1 exponent 2, it will become times 2 times x minus 1. All divided by the square of the denominator, which is x plus 3 squared, then times x minus 1 squared, all squared will become exponent 4. So this is equal to minus. Now, what we can do, so this is equal to, what we can do in this case is, let's factorize x minus 1 since it appears in both sides. So minus x minus 1, then times, we'll be left with x minus 1, then here will be 2 times plus 2 times x plus 3 divided by x plus 3 squared, then x minus 1 exponent 4. So this x minus 1 can cancel one of this because there are 4 here. So this is equal to minus into brackets x minus 1, then 2 times x is plus 2x, and 2 times 3 is plus 6, divided by x plus 3 squared, then x minus 1 exponent 3. So this is equal to, now x plus 2x becomes 3x, then minus 1 plus 6 becomes plus 5, divided by x plus 3, then x minus 1 cube. So now let's find the critical values. Remember, we said critical values are the values for which f prime of x is equal to 0 or f prime of x does not exist. So now that means that we need to equate this numerator to 0. So 3x plus 5 equals 0. X is equal to minus 5 over 3. So this is one of the critical values. And this is when f prime of x is equal to 0. Now, what about undefined? It will only be undefined if the denominator is equal to 0. So we need to equate x plus 3 times x minus 1 cubed equals 0. So you see that x plus 3 equals 0. X is equal to minus 3. It's also one of the critical values. And then x minus 1 equals 0. Since the multiplicity here is odd, then we won't get two values here. We only get one value, which is x equals 1. So therefore, the critical values are x equals 1, x equals minus 3, and x equals minus 5 over 3. So let's put that on a number line. So this is our number line. So we have minus 3 here, minus 5 over 3, and then 1. So here is infinity, and here is minus infinity. So let's take values less than minus 3. For example, minus 4. So now you see that there is already a minus here. So there is minus here. Now 3 times minus 4 is minus 12 plus 5, which will give us a negative value, divided by minus 4 minus 3 is a negative value. Then minus 4 minus 1 is minus 5. Cubed will also give a negative value. So at the end of the day, we are going to get negative times negative is positive, divided by negative times negative, so positive. So with this, a positive region. So this region is greater than 0. Now let's come to a value between minus 3 and then minus 5 over 3. Minus 5 over 3 is around minus 1.66. So which will be, let's assume minus 2. Let's take minus 2. So now, if we put minus 2 in the numerator, 3 times minus 2 is minus 6. Minus 6 plus 5 is minus 1. So we have minus times minus divided by. Now, minus 2 plus 3 is positive. Then minus 2 minus 3 is negative. So we have a positive value, then times a negative value. So this one and this one will cancel out. So this region is a negative region, or it is less than 0. And then now, let's come to this region. A value between minus 5 over 3 and 1. Let's take 0. So we have negative here. Now, if you put 0 in this equation, 3 times 0 is 0 plus 5. So this is a positive value. Then 0 plus 3 is a positive value. Then times 0 minus 1 is minus 1 cube, still a negative value. So at the end of the day, it becomes negative times positive is negative, divided by negative times positive. So this is a positive region, or a region greater than 0. Now let's take a value greater than 1, for example 2. So there's already a negative here. 3 times 2 is 6. 6 plus 5 is 11. So this is a positive value. Then here's 2 plus 3 is 5. So it's a positive value. Then 2 minus 1 is 1, which is also a positive value. So at the end of the day, this region is a negative region. So now, let's find the values of x for which the function is decreasing. So it's decreasing in all the intervals where f prime of x is less than 0. So we are talking about minus 3 and minus 5 over 3 union this other region, which is 1 and then infinity. Now let's talk about region in which it is increasing. So you see that the function is increasing in this region, and then it is also increasing in this region. So we are talking about minus infinity and then minus 3 union minus 5 over 3 and then 1. So this is the region in which it is increasing. So let's consider this function. We are supposed to determine the interval for which the function is decreasing, increasing the concavity, and also whether it is local minimum, local maximum, or the points of inflection. So now we need to find f prime of x, and that is equal to, if you differentiate x cubed, we get 3x squared. If you differentiate 6x squared, we get minus 12x. If you differentiate 9x, you get plus 9. And if you differentiate 30, is 0. So f prime of x, let's factorize 3 out. So it becomes 3 then times x squared minus 3x plus 3. Sorry, minus 4x plus 3. So we are looking for two values in which when you multiply, you will get 3, but when you add, you get -4. So those values are -3 and -1. So f prime of x will become 3 times x minus 1, then x minus 3. So the critical values are x equals 1 and x equals 3. So let's sketch it on a number line. So this is 1 and then this is 3. Here's minus infinity. And then this is plus infinity. So now let's take values less than 1. For example, 0. If you put 0 in this function, 0 minus 1 is -1. 0 minus 3 is -3. -1 times -3 is +3. So this region is positive. Then between 1 and 3, we are having, let's choose 2. 2 minus 1 is 1. Then 2 minus 3 is -1. So 1 times -1 is -1. So this value is less, this region is less than 0. Then in this region, let's choose a value between 3 and infinity. For example, 4. 4 minus 1 is 3. Then 4 minus 3 is 1. 3 times 1 is 3. So this region is greater than 0. So now, what are the interval for which the function is increasing? So it's increasing in this interval and also increasing in this interval, which is minus infinity and 1, then union 3 and infinity. Then what is the interval for which it is decreasing? So it's decreasing in this interval, which is 1 and then 3. Let's find the values for whether it is either a local minimum or a local maximum. Now we are going from positive to negative, so it means that this is, at this point, x equals 1, we are having a local maximum. Then we are going from a negative to a positive, so at this point we are having a local minimum. Now let's find the concavity. In order to find the concavity, we need to find the second derivative of x. So let's differentiate this. If you differentiate 3x squared, you get 6x. If you differentiate minus 12x, you get minus 12. So now, let's find the point of inflection. So the point of inflection will occur for which the second derivative is equal to 0. So 6x minus 12 is equal to 0. Therefore, x is equal to 2. So the value of x for inflection is x equals 2. Then now, let's sketch this on a number line. So this is 2. Let's take values less than 2. For example, 0. If we put here, 6 times 0 is 0. 0 minus 12 is minus 12. So this side is negative. And then let's take values greater than 2. For example, 3. 6 times 3 is 18. 18 minus 12 is 6. So this part is positive. Concave up occurs for where the second derivative is greater than 0. So the concave up situation is 2 and infinity. And then concave down is minus infinity and then 2.